All right, so good morning, guys. So today we are going to start our first of 2 days graphing what we call square root equations. So square root equations are different than pretty much everything that we've seen, but they're also going to look very similar to something else that we've seen, just kind of in a different way. So that's not really going to make sense until we see it. This is really one lesson that we're spreading out over 2 days. So one of the things I said the last couple of weeks is we're kind of, trying to stretch things out a little bit. Teaching remotely is a little bit different than doing it face-to-face as far as obviously not being able to ask the same amount of questions. So I'm trying to really take things slow. Even if I go through the lesson kind of fast, you can always pause and go back. But as far as the content, I'm really trying to stretch it out here, to just create like a deeper understanding of everything for us. So let's start with the really basic one, right? Y equals square root of x. So initially, obviously, guys, for any equation like this, that's not a linear equation, we're going to lean on our calculators for a lot of it. So before we start with something like this, or why don't we start with something like this, we're going to realize that we have a problem. When we put this in our calculators, we're not going to get anything here, right? Different calculators say different things. Sometimes they say error, sometimes they say non-real solution. The reason is if we try to take the square root of -2, we have a problem, right? It's an imaginary number, which we don't get into at all. I mean, other than seeing it in the context of a quadratic equation, it's not something we take any further. So we are not going to be using any negative values here, all right? So if I see some negative values, and this is not pointed at you, student who is watching my video diligently and taking notes, but if I see negative values in other people's, I'm going to know that, you weren't doing the right thing. So we're not going to use any negative values for this specific one, at least. So let's start with 0, and let's start with 1 and 2. And again, if you look at your calculators there, you're not going to have a really great answer for 2. You're going to have 1.4 something, 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 right? Because radical 2 is an irrational number. Am I going to want to plot that on my graph? I'm not unless I have to. So if I was doing this in class, the next question would be, what kind of values of x am I going to use? And I'm sure you're sitting there raising your hand in your bedroom right now saying, you're going to use perfect squares, Mr. Capasso. And I'm going to say, wow, that's so intelligent. That is correct. So let's look at some perfect squares. And we may not be able to graph necessarily all of these, but at least we will get integer solutions. Right? And again, you can get these from your calculator. All I'm doing in my head is I'm taking the square root of my x values. So the square root of 0 is 0, the square root of 1 is 1, the square root of 4 is 2, and so on. So when I plot these values, I'm going to end up with something that looks like this. Now, a couple things that we have to consider here, right? The first one is, are we going to use arrows? So let me connect these points. And I know that there's going to be a point 16,4 kind of out here, but I don't get to it. But I need to express on my graph that eventually my graph will get to it. So I probably, and it's a little hard, I don't have a whole lot of space here, I don't need to go off my graph, but I definitely need an arrow to show that this graph extends indefinitely. Am I going to have an arrow down over here on the left side? I'm not, because we said negative values are not in the domain. If somebody said, what is the domain of this graph? The domain is x is greater than or equal to 0. Because if x is 0, I get 0. If x is anything greater, even if it's something like 7, right? Radical 7 is still a real number. I can't have x is equal to -4. Okay, so my domain is x is equal to 0. Greater than or equal to 0, and also my y values. If I wanted my range, those have to be greater than or equal to 0. There's nothing I can do to give me a y value that's negative. Now, what's the connection here? Well, it doesn't really look like it the way I drew it. I didn't do a great job drawing this, but what would happen if, let's say, and this is not something that's necessary here, but just as a little extension, what would it look like if I square both sides? X is equal to y squared. So what is this really the graph of? This is, and you'll learn this, you won't do this next year, you'll do it the year after. This is really a sideways parabola, okay? So we know that y is equal to x squared is a parabola. And some of us did this. A couple of you guys have asked this in class when we did parabolas, and we said, well, what would happen if we switched the variables around? And I said, well, if you switch the variables around, it actually rotates your parabola 90 degrees. It makes it sideways, and that's what this is. Now, why is it only half of that? Well, because we can't get any negative values here, right? There's no x values and y values that are negative, so it's literally only half of that parabola. So that's just something to think about. That's why I was saying at the beginning, initially, seeing a graph that looks like this doesn't exactly look like things we've seen. But if you think about it in the context of this, it's actually half of a parabola lying on its side. All right, so let's look at something like this. Radical x plus 3. So we're still not going to be able to have any x values, right? So I'm going to still start with 0, and I'm still going to just use some perfect squares. So what's going to happen? Again, you guys can put this in your calculator. Just make sure when you put this in your calculator, just the x is in the radical. What you're going to have to do is you're going to hit the radical button, you're going to hit the x, and then you're going to have to toggle over to the right on your calculator. Otherwise, it's going to put the plus 3 in the radical like this, which we will see, but that's not what this question is saying. This is basically saying take the square root of x and then add 3 to it. So square root of 0 is 0 plus 3 is 3. Square root of 1 is 1 plus 3 is 4. Square root of 4 is 2 plus 3 is 5. Square root of 9 is 3 plus 3 is 6. And square root of 16 is 4 plus 3 is 7. So let's see what this looks like now when I graph it. So I'm going to graph 0, 3. I'm going to graph 1, 4. I'm going to graph 4, 5. And I'm going to graph 9, 6. And I'm going to do exactly what I did last time. Oh, and I'm sorry, what I did not do, and I, for some reason, I have a habit of doing this on my first slides, I've noticed, is labeling. So make sure that we label the original equation. So make sure when you guys are doing your homework tonight that you're labeling the equation. Now we're going to say, this looks really similar to the one we just did. So let's go back to the one we just did, and let's look at the table. 0, 1, 2, 3, 4. 3, 4, 5, 6, 7. What did we do? And somebody would raise their hand and say, you shifted it 3 units up. I'm going to say, wow, we should really make some connections to something we did right before we went on break, and even something we did back in December, I think, which is translating graphs. So when we translate a parabola or an absolute value equation, if we had a plus 3 outside the equation, it would translate it 3 units up. So it's another parallel, another throwback to those translations of absolute value graphs and translations of parabolas. I don't think I have to do this one, right? So what do we think is going to happen? Plus 3 outside caused us to go 3 units up. What is minus 5 outside going to do? It's going to shift us 5 units down. So I don't need to actually do the graph, I'm sure, and you can look at it in your calculator if you'd like, but it's going to basically take the exact same graph we had originally, and instead of shifting it 3 units up like we see here, it's going to shift it 5 units down. All right, something here that we see on the region sometimes is they ask you to graph something. Now it says over the domain -4 to +5. So they only want us to use -4 through +5, and really there should be or equal signs here. So we're going to say, all right, those are the only values they want me to graph. Now I'm probably not going to want to graph all of them, right? So I can use -4. And again, now when we put this in our calculator, we do want the whole x plus 4 to be inside our radical. So what's going to happen when I use -3? Well, that's going to be fine. What's going to happen when I use -2? Well, I don't want to see radical 2. What's going to happen when I use -1? I don't want to see radical 3. Right? What's going to happen when I use 0? Okay, I'm okay with 0. What's going to happen for the next bunch? Well, nothing good is going to happen until 5. And by nothing good, I just mean you're going to get decimals. Could we graph every single value? Sure, you could, but really we only want the y values that are integers or that are rational numbers. In other words, I'd take a half or a quarter, but I don't want 1.37562, going on indefinitely. And then the next one that we can get, I believe, is going to be 12 here. So let's take a look at my y values now. So this is going to give me 0. Oh, I take that back. I was not following their rules. So it only wants us to graph the values between -4 and 5 inclusive. That's it. So what happens when I use -3? It gives me 1. What happens when, and again, guys, you're getting these right from your calculator. I mean, it's easy enough. I'm doing it, just popping them in my head. But, you could use your calculator. It's pretty easy to just sub them in mentally. So these are the only values they want. So if you did this in the Regents and you graphed any other values, they're going to take off a point because now you're just graphing it. You're not following their directions. So now we've got -4, 0 is out here. I've got -3, 1 is here. I've got 0, 2 is here. And I've got 5, 3, which is going to be up here. Now this is a little bit different. Okay, so I'm still going to label it, but I'm not going to use arrows. Arrows would imply that this graph continues indefinitely, which in the real world, it would continue indefinitely to the right, but they're only asking us for part of it. They're saying, I don't want this entire graph, right? I just want it from here to here. So that's what we're going to give them. We're going to give them the part that they want. So again, this isn't something we generally see. You know, if I was doing this in class, I wouldn't assign this. But since this has showed up a lot on the Regents, it's good practice to get us ready for what we might see next year. And of course, what was the shift? So let's talk about it. Well, what did I do? It looks like I shifted from here, my original vertex, out here. So I shifted 4 units left. And again, some of us, before I even asked the question, if I was doing this in class, the light bulb would go off and we'd say, hey, wait. When we did absolute value graphs, a +4 inside shifted us to the left. And when we did parabolas, a +4 inside the parentheses shifted us to the left. So again, it's another connection of that same concept of shifting absolute value graphs and shifting parabolas. So what can we pretty much tell is going to happen here? Well, that -5 inside tells me I should shift 5 units right. Now I'm going to do it just to make sure, but it tells me I should be shifting 5 units to the right. So where am I going to start here? Well, the smallest value I'm going to use here is going to be 5. Right? What happens if I use 3? Well, it's going to give me radical -2. So the smallest value of x I'm going to use is the value that gives me a 0 inside the radical, which is going to be 5. Then I'm going to jump to 6, which is going to give me 1. Then I'm going to jump to 9, which is going to give me 4. And once again, guys, you can see this in your calculators if you'd like, but hopefully it's catching on for some of us. That might even be faster just to kind of do it by hand. And the next one that we're going to use is going to be, what, 14? And that should be 2. So let's see what this looks like. I'm not going to be able to graph a whole lot of these, unfortunately, right? So I've got 5, 0 out here. I've got 6, 1. I've got 9, 2, and then I kind of get cut off. So I've got y equals absolute radical x minus 5. And it turns out that we were exactly right. We expected this from the -5 in the radical to move us 5 units right, and it did in fact move my original graph, which were centered at the origin, 5 units out to the right. All right, guys, so there's your homework. So you're going to graph each on a separate plane. So in other words, I want 2 graphs. I want a graph for number 1. I want a separate graph for number 2. So number 1, we would expect perhaps to move us 3 units down as a little hint. And number 2, we would perhaps expect to move us 3 units to the right, as we just saw. So it should be a nice, easy homework assignment. As always, guys, any questions, concerns you have, send me a comment, send me a message, and we can talk about it, or you see me in the weekly Google chat.